9 o'clock, Sunday, May 7th.
Dad, you told me to stand back.
9 o'clock, Sunday, May 7th. Because of daylight savings time, we do 9 o'clock. We're doing this experiment at 9 o'clock because 2 months ago, it was actually 8 o'clock at the same point in this day. But anyway, start this video at the beginning of the ruler, on the left side of the ruler. We're going to time it to see how long it takes, the same time of day, 2 months later, for the sunline to move. But I also want to note that, yeah, we are 2 months later, on May the 7th. Okay, and now the sunline, this is the same sunline. This part right here that was over here. So the sunline has moved from over here to over here. Sorry, over here down to here, the same time of day. Okay, and so what I'm showing here is the time it takes now and the location now for the sunline test. This is the second sunline test. It's 2 months later. We started this video when the left sunline was at the beginning of the ruler, and now we're just going to time it to see the discrepancy in time. Now it's 2 months later. Basically what we're showing here, 2 months earlier, March the 4th, it took 2 minutes and 30 seconds to cover this ruler, for the sunline to cover this ruler. Now it's May the 7th, if I'm not mistaken. Yeah, now it's May the 7th, and it's already been 3 minutes. And it's just marked the halfway point of the ruler. So what this is telling me is that the sun has moved positions, of course, which is also explained by the globular theory as well. But the sunline is in a completely different location on my grid of my house in comparison to where it was. And now the speed of the sunline is moving at a substantially slower rate, because when the sun is closer to you, these sun rays move slower across surfaces, across areas. And when the sun is further away, these sun rays are going to move faster across the floor. But anyway, so it looks like we're going to double the time here. So it's doubling the time. So even still, on a flat Earth model with the circular path of the sun, in the summer months, that circular path is tighter around the North Pole. So it's like a shorter circular path, but the sun is also moving slower. In the wintertime, the sun is on the outer edges of the disk, if you will, moving at a much faster rate. So even if when it's approaching from the winter to the summer, of course, like springtime or March 4th, that's what we did the initial experiment, then you'll notice that the difference that the sunlight moves faster in March at the same time that it does, at the same time of day that it does in May. And that's basically what we're showing here. So we're gonna let the ruler go ahead and get covered up and show y'all that it's still not covered up. Still got a good ways to go, but we said, make sure you watch my first video First video shows that basically the premise of this experiment, how we're going about doing it, what we deem complete. We're still in action. You know, the ruler's still lit up. We have a kind of like a transparent red ruler, so the ruler's still lit up. If it's lit up, then that means that the sunlight is still hitting it. So it has not passed. We'll let it go ahead and get passed. Okay, we can go ahead and call it. We'll call this one 5 minutes and 45 seconds. We're calling this at 5 minutes and 45 seconds. This is our experiment. 9 a.m. May the 7th, 2 months and a couple of days after our initial experiment. Basically, what we're showing is that as opposed to only taking 2 minutes and 30 seconds to cover this ruler, it's now taking 5 minutes and 45 seconds to cover the ruler. Okay, even on the flat Earth model, the sun has moved closer to us because we are approaching summertime. It's closer overhead. Therefore, the sunlight is going to move much slower. And it's at the point in my house to which my last experiment, if you watch my last video, this was later in the day. So it was an hour later until we were here at this grid or this portal, whatever you want to call these lanes. Since I was coming down the grid doing my measurements, I was into my ninth portal or whatever. And this is in essence like the ninth portal. And so that wasn't until 9 o'clock. So this didn't happen until an hour later, 2 months ago. So basically, we did this experiment at 9. If I had done this experiment at 10 o'clock, in my initial experiment, I would have seen sunlight over here like this. I don't know if it would have been in the same spot, but it would have been over here in this area because it would have been later on in the morning. It's earlier in the morning when I started. The sunlight was moving much faster. 2 months ago, it was over there, 2 minutes and 30 seconds. Now at the same time, 2 months later, you saw here that it took 5 minutes and 45 seconds, over double the time for the sunlight to move.